How are you everybody? How are you today? This is the 9th lecture in our course Statistical Model in Econometrics. This is for 4th year English section, Banha University 2020. This lecture is related to multiple linear regression estimators and coefficients. It's a very important lecture and I want from every student to study this lecture very closely. Multiple linear regression estimators. This is lecture related to also the multiple linear regression and the estimation of betas and the coefficient of the multiple regression model. This is an important lecture in our course and this is the 9th lecture, and I want from every student to study this lecture very closely. Consistency of estimator. Letter A, consistency of B, the slope of the linear regression model under the assumption that limit n go to infinity, x dash x over n equal delta exists as non-stochastic and non-singular matrix with finite elements. We have limit n go to infinity, variance b equals sigma square limit n go to infinity 1 over n x dash x over n to the power minus 1 equals sigma square len n goes to infinity 1 over n small delta to the power minus 1. This is equal 0. This implies the ordinary least square estimators converges to B. What is the meaning of equal 0? Equal 0 means that ordinary least square converges to beta in quadratic mean. Thus, ordinary least square is consistent estimator of beta, a good estimator. A good estimator of beta, the parameters, the coefficients of the linear regression model, the parameters or the coefficient of linear regression model. This holds true for maximum likelihood estimators. Thus, ordinary least square estimator is a consistent estimator of beta, Thus, attain true for maximum likelihood estimators also. This is a very important characteristics of the slope B, small b, as a consistent ordinary least square estimator for the multiple linear regression in quadratic mean. And this means that this holds true for maximum likelihood estimators. It's very important and I want students to study this part very closely. Letter B, consistency of S square. Now we look at the consistency of S square as an estimator of sigma square as S square equal 1 over n minus k e dash e. And this is a mathematical induction. 1 over n minus k is e epsilon bar multiplied by the hat matrix h bar multiplied by epsilon. We goes to the ending of the proof. Note that epsilon bar multiplied by epsilon over n consists of 1 over n summation epsilon I square and summation epsilon I square equal I equal 1 to up to n is a sequence of independently and identically distributed random variables with mean sigma square. Again, epsilon bar multiplied by epsilon over n consists of 1 over n summation epsilon I square, and the epsilon I square I, the values of r from 1 up to small n, is the sequence of independently and identically distributed or distributed mean distributed random variables with mean sigma square. Using the law of large number, we can show that. After we ending the mathematical induction and applying the law of large number, we can found that S square equals sigma square. Thus, sigma square, S square, is a consistent estimator of sigma square. The same holds true for maximum likelihood also. Again, after we ending the mathematical induction, the mathematical proof related to the consistency of S square, we can found that S square equals sigma square, so that S square is a consistent estimator of sigma square. Again, after we ending the mathematical induction, the mathematical proof about S square, we can find that S square equals sigma square, so that this conversion between S square and sigma square means that S square is a consistent estimator of sigma square. The same holds true for maximum likelihood estimators also. Now, standardized regression coefficient is very important topic about standardization regression coefficient. Usually, it is difficult to compare the regression coefficients because the magnitude of beta hat j reflects the units of measurement of jth explanatory variable xj. For example, in the following fitted regression model, y hat equal 5 plus x1 plus 1000 x2. Y is measured in lines, in letters. Y is measured in letters. X1 in letters and x2 in milliliters. Although beta hat 2 greater than beta hat 1. But the effect of both explanatory variable is identical. One line change in either x1 and x2 when another variable is held fixed produces the same change as y hat. Sometimes it is helpful to work with scaled explanatory variables and study variable that produces dimensional regression coefficients. These regression coefficients are called a standardized regression coefficient. There are two popular approaches for scaling which gives standardized regression coefficients. We discuss them as follows. This is what I mean by standardization of regression coefficients. It's very important from every student to study this lecture very closely and know what is the meaning of standardization regression coefficients. Unit normal scaling. Employ unit normal scaling to each explanatory variable and study variable so defined. Zj y star I, and this unit normal scaling all the scaled explanatory variable and the scaled study variable has mean 0 and sample variance unity, i.e. using this new variable, the regression model becomes. This is the new regression model after normal scaling, after normal standardizing. This is what I mean by standardization. Z equal xij minus xj bar over sj. yi star equal yi minus y bar over sy. Or sj square equal 1 over n minus 1 summation xij minus xj bar square, and sy square equal 1 over n minus 1 multiplied by summation I from 1 to n yi minus y bar to the power 2. This is what I mean by sj and sy, sj square and sy square, and sy and sj is variance and standard deviation for the sample. All scaled explanatory variable and scaled study variable has mean equal 0 and sample variance unity. Number 1, What is the meaning of unity? Unity means equal ones. Very important to know from every student very closely. i.e. using this new variable, the regression model becomes yi star equal y1 z j1 z11 plus y2 z12 up to epsilon and I equal 1 from up to small n. Such centering removes the intercept term from the model. The least square estimators of y is y hat z dash z to the power minus 1 z dash multiplied by y star. This scaling has a similarity to standardizing normal random variable, i.e. what is the meaning? Meaning observation units its mean and divided by its standard deviation, so it is scaled, so it's called as a unit normal scaling, so it's called as a unit normal scaling. Thank you for everybody. See you in the next lecture in the faculty and on the faculty website. Thank you for everybody.